to solve problems in your project. My name is Guilherme and I'm a project management expert. I help professionals to become successful project managers. How I do that in practice can vary from a lot of different things from mentoring, consulting, coaching, and even providing training, and also providing a lot of free content here. Before I forget, make sure you like and share this video here so it can reach more people and more people can learn project management. And also, this content here is part of the warm-up of the Project Management Summit. The Project Management Summit, it's a free event I'm going to make to help you to further develop your project management skills. This event is for people starting with project management. If you don't know how to start, if you want to start to develop your give you the first steps, but also for people that's already working with project management but did not have any formal training. It's a free event. You get a certificate in the end, so make sure you click in the link in the description of this video and subscribe. Well, the topic I'm going to talk about today is problem solving. Problem solving is one of the very essential and key skills of any project management. Why? Because whatever the type of problem of project that you have, what I can guarantee to you is that you're going to face problems. Problems are a natural part of any project. And of course any project, but also any type of work that you do. You're going to, of course, the level that you are in your project management or your career and so on is based on the type of problems that you can solve. You can imagine that, for example, a project coordinator, a junior project manager, the type of problems that they can handle it, it's different than what you are going to expect from a senior project manager. That's of course why a senior project manager in general should have a better salary there. So keep in mind that solving problems, it's a good way to evolve into your career. More problems that you can solve, more complex the problems that you can solve, that of course will open different type of doors that you can go. That means that you are going to have possibilities for promotion, for going up into organization, to handle bigger projects, to handle more complex projects. So problem solving is a key skill if you want to for your life. So if you want to be an entrepreneur, if you want to be a manager, a director, keep in mind that you need to be good in solving problems there. So, and of course, why it's interesting if you want to be a manager or a director also to develop your project management skills, because project management will help you to develop your problem solving skills, but it will help you to organize and execute everything that you need to do there. So talking about problem solving there. I've already mentioned that regardless the project that you're going to have, you're going to face problems there. You're going to face, depending on the type of project, of course, but you can face problems from project delays, from quality issues, like if you're developing a product, the product simply fail in a qualification test, in a validation test, and you need to figure out how you're going to approach to solve those problems there. So there are several different type of problem solving frameworks. Of course, some are more pertinent in different situations. So you can have iterative improvement frameworks. You can have a root cause analysis. You can look for creative solutions there if you're trying to develop something new. You can look for type of problems that's in a strategic decision making and so on. But that's why I have this overview here. There's a lot of different type of problem solving. For example, talking about a few of them very briefly. You have the MIC. The MIC comes from Six Sigma. Basically, it's an acronym for Define, Measure, Analyze, Improve, and Control. So this is a type of problem solving framework that's very used once you have data to analyze there. You can also have the PDCA, plan, do, check, and act. You can have lean problem solving. Lean problem solving, what's the idea? You identify the problem, you analyze the process, identify waste, because what's the goal of lean is to make things cheaper and faster with higher quality. So how they do that is identifying waste, and of course you identify waste, so you develop and implement solutions. How you identify the waste can go for value stream mapping and so on. But you also have 8 steps of practical problem solving. How you do that? You clarify the problem, you break down the problem, you set a target, analyze the root cause, develop countermeasures, see countermeasures done, Evaluate both results and process and standardize success. So you want to keep going. You have 8D problem solving. 8D stands for 8 disciplines there. So you create a team, you define and describe the problem, contain the problem, and so on. What and why I'm presenting to you few of those, and I could go on talking about ProAct. So you always define a problem. Why it's important? First, you understand there are several different frameworks. Some are more suitable for specific situations. Some companies they like one or another. Some types of industries they have one or another as a standard. For example, 8D, it's a standard that you see very often in a lot of different industries, mainly manufacturing. It's quite used in automotive, semiconductor, and so on. Because once they have a problem, they say, okay, start an 8D. So there's a standard way to execute this problem, and you move forward. But why I presented to you few options here, problem, 8 steps for problem solving, Lean, the mic, and so on. So what you're going to see that's common in all those frameworks is, first of all, investing time to understand the problem that you have. Because understanding the problem that you have, it's essential for you to work into a solution. Let me make a very simple analogy here to try to make you understand. Let's say that you have a car and one day your car is not turning on. You try to go it and the car it seems to be dead. So you call a mechanic there and this mechanic comes, say, okay, usually what happens quite often, why cars they do not turn on, it's because the battery is dead. Maybe the car was there for a long time, maybe it's winter time, maybe the battery is old, whatever reason, the battery there, so you cannot turn on the car. Very simple problem, right? So what the mechanic does, he goes and he changes the battery of the car. And suddenly he tries to turn on the car again, and the car still does not work. And after some checking, he comes up and he finds out the car is actually without gasoline. There's no fuel in the car. That's why the car is not turning on. So why I'm making this analogy with the car here? Because it's a very simple way to showcase that if you have, if you are trying to solve the wrong problem, you're not going to find a solution. In the case of the mechanic, he jump on in a conclusion and say, okay, very often cars they do not turn on because of the battery. So probably the problem is the battery. So he was just looking to a symptom. He make an assumption about the root cause. He wasted time. He wasted resources there because changing the battery takes time. There's a cost of new battery on top of his hours, and also it took him much longer to figure out the problem because instead of looking for what okay to understand the problem to understand the root cause, he was trying to fix something, and then he ended up taking longer to solve the problem, wasting resources and so on. So this is a very simple analogy to show to you why it's so important to fully understand the root cause of the problem that you're trying to solve. But you cannot fully understand the root cause. You're going to have challenges with that if you have a problem identifying if you have a challenge first of all to identify the problem. Again, with another analogy, it's exactly the same thing when you go to the doctor. If you go to the doctor because say I'm sick, what the doctor will ask you, okay, what are your symptoms? Why? Because the doctor is trying to understand the kind of problem you have, and based on your symptoms, the doctor can understand, okay, what type of disease that you have. But you see very often in projects and in companies, people trying to solve problems, first of all, without really understanding what's the problem, and second, without really understanding what's the root cause. And what happens? People jump on and stuff, and they start work, waste time, waste resource, and they figure out by the end, okay, I'm trying to solve the wrong type of problem. And something here that's also quite important is understanding to fully understand the problem because sometimes you can have several different symptoms there or sometimes even you can have if you break down the problem you find out smaller problems inside of it. You need to understand that you need to prioritize what you need to do. For example, I've worked with mentoring a production manager there that from my small factory. So they were trying to understand how to improve the factory there. And she started to go looked into deep how to track small amount of waste that could have in the process and so on. And that's of course waste is always a problem. It's always nice to minimize it. But the first thing I asked her was, okay, what's your challenge right now? Your challenge is that you want to produce more. Well, so your first goal there is to produce more. Identifying waste of material, it's important. It can help you to reduce the cost. Yes. Is that the most important problem that you need to tackle right now? In this case, it was not. Because if you want to produce more, although you wasted, save 1% of extra material, that will not solve you to improve the capacity of the plant the way you want to do there. So making sure that you're also tackling the right problem there, it's very important. Why I'm saying that? Because if you're going to work in a project, you're going to face all types of issues there, all types of problems that you can have there. And so first, you need to understand those problems there, why it's important to understand, not just so you work on the root cause, but also you prioritize. I've had projects, for example, where there was a problem. It was a manufacturing project that there was a problem of yield loss because a specific parameter on the equipment was not as we expected, so it was causing a yield loss of 0.1%. And then this was one of the problems that we had. But 1% in this business case over a 10-year production window based on a forecast that we had there, it would cause a cost of thousand of euros, 1,000 euros or 1,000 of dollars. I don't remember exactly the currency, but 1,000 of dollars over 10 years. Oh, if you divide by 10, you are talking about $100 per year. That does not make sense to prioritize your team work to solve a problem like that. What did I do? I just accepted the loss. $100, that's nothing. So make sure that you understand the problem before. It's quite important. It's quite relevant there. Yeah, and making going back to the analogy of the car there. If you are in an urgent situation and then you find out, then the mechanic when they check there, they find out that you have two issues. One issue, for example, the battery is dead, but also there's something on the air conditioning that's not working as it should. The temperature is not as well regulated or whatever, something like that. But you need the car for an urgent item. And what you're going to tell the mechanic? Okay, you solve both problems. Then they say, so for the air conditioning, we need to take the car for the garage, and it will take 2 or 3 days to solve it because whatever, we need to change the sensor. Or you're going to tell him, okay, change the battery because I need to the car right now. This is a very simple analogy to show you how important it's you to understand the type of problems that you have and also to make sure that you understand how you're going to prioritize the solution of those problems. And I give you even an example that some of the problems that you have in your project, I just accept the problem without even further detailing the root cause. Why? Because the effort to solve the problem itself, it did not worth it. So you are going to have all types of problems in your project. What you need to understand is filter which ones matter, and for doing that, you need to understand the problem. And understanding the problem is okay, what you are trying to solve here, and you understand the problem, and then you are going to prioritize. Once you prioritize, you're going to understand the root cause. Again, going back to the same analogy here of the car, you're not going to try to just try solutions. And if you try a lot of different solutions for a problem that you just don't know the root cause, it's kind of guessing work. You might be very lucky, then you might guess a solution that solves the root cause, or you can stick with that forever, or not forever, but for a long period of time. So what's important? You're going to invest time, understand the root cause before jumping onto all those kinds of solutions. And what's important if you are into a root cause investigation? I already mentioned the analogy of the mechanic, but it's important that you understand the difference between a root cause hypothesis and a root cause confirmation. What do I mean by that? In the case of the mechanic here, the battery that was dead, it was a hypothesis. It was not a root cause confirmation. So it's very important that have you can have all the hypotheses, and of course there's different ways that you come up with hypotheses. For example, you can use the fishbone diagram or Ishikawa diagram. You can look for the different dimensions like manpower, machine, method, and environment, material, and measurement. You can use 5Y, or you can use other types of framework there, like fault tree analysis, FMEA, current reality tree. You can use, if you have data, Pareto analysis, scatter diagram, histogram. There's all types of things that can help you in the root cause identification. What's very important is when you are working this root cause investigation, mainly if you're working with a fishbone diagram and the 4 or 5 whys, is that you understand that in a lot of things that you're going to be working there, you are working to identify hypotheses there. In the case of the analogy of the car, what's the hypothesis? The battery is dead. That's a hypothesis. What's the other one? The car does not have gasoline. What is the other one? I don't know. Maybe there's a problem in the injection system. That's why the car. You have all those kinds of root cause hypothesis. So it's very important that you work on root cause confirmation. And for making sure that you are going to do that, you need to fully understand what you have in your hands. Because in the same case as the mechanic there, you are going to see that a lot of people, they jump into solutions and they try to solve what are hypotheses. In the same case that I mentioned for the analogy of the car there, what's going to happen there? You are going to waste resource, you are going to waste time before you even find out what kind of problem that you have there. So what's the difference between a hypothesis and a root cause confirmation, which I hope that you understand right now. Hypothesis is an idea, a potential cause of something, and when you have a root cause confirmed, we are going to look into data analysis. You're going to test, you're going to make the experiments to confirm that's going to do there. What, in the case of the analogy that I mentioned about the mechanic, what would be a way to confirm it? Oh, I think the battery is dead. Usually they have an instrument, they just check what's the power level in the battery. And they see, okay, the battery is still good, so it's not the battery. So you look for the next root cause. Oh, then you look for the fuel level. Oh, the fuel level is empty. So likely the lack of gasoline is the root cause. And of course, in the case of gasoline, how we would confirm it? Put some gasoline and try to turn in the car. And if it works, then okay, now the gasoline it's confirmed, right? So keep that in mind. Be careful in not jumping into solutions based on hypotheses there. Very common mistake. And once you're looking for data for your solutions there, what's very important that you also realize what kind of data that you have into your hands. And that's, of course, when you talk about data, you're going to talk about all types of evidence there. And you can talk, and that's also why I like this graph here, because there's different types of evidence that you can have. For example, maybe the evidence there that you can, if you prefer, you can call. I had a discussion with somebody some time ago. He said, for me, everything here is data. Because of course, a story, it's a data. Observation, it's a data. Yes, if you look like that, all those things are data points. So the point that I'm trying to make here for the evidence is what confidence level that you have based on this evidence and what action that you can take based on this evidence. For example, the analogy of the car. You are telling the mechanic the car is dead, does not turn in. So that's something that you're telling. And you can say, I think it's the battery. So this is a story that you are telling the mechanic there. Why it's important for you to understand the different type of evidence that you have there to support your root cause. Because depending on the different type of the evidence that you have there, you're going to look for more evidence. In the case of the mechanic, the analogy of the car, I'm telling the guy that's saying, oh, I think it's the battery. It's a story, right? Why? Because I don't have any data to back this up. It's just a conclusion, an assumption from my part. Maybe I saw that very commonly, maybe it was winter time, and very commonly batteries die during the winter time, for depending on the age of the battery and so on. So keep that in mind. What would be a hard data that would provide a very high confidence level there? The mechanic measuring the battery there to make sure, okay, the battery is dead, really dead, so let's change it. Or no, the battery is good, so probably there's another root cause there. What can so understanding the type of evidence that you have, it's essential. And you have the opposite, of course, stories that someone is telling you, someone told you something. You can see something that's also, of course, it's a bit higher level of confidence, but just because you saw something does not mean necessarily that you can take a conclusion based on that, because you might see a limited perspective there. But you can have like procedures, you can have cards, you can have a Kanban system to look for the data that you have there. And you have data that should be high evidence, like measurement, the data itself, key performance indicator. And in the discussion that I have about the type of evidence, be careful also with key performance indicators. Of course, it's a better data than a story that someone telling you, but there's also different level of qualities of indicators there. There are companies using indicators there as a kind of feeling. I've already talked about that in different types of content, where people say they have key performance indicators that's based on project manager feeling. Is the project is on track? Yes or no? The project manager say, I think it yes. Based on what? If the key performance indicator is not based on data, so that's the best thing that you can have. Your key performance indicator is a story. So having those different levels of understanding will help you to understand how you solve problems. That's why it's always good to look for things are happening. And when you look, for example, for Lean, Lean comes from the Toyota production system, and one of the things that they have very hard to solve problems is they call it the go to Gemba. Gemba is basically a Japanese word that reflects where where the work is done. The idea is go to Gemba is to see by yourself, to really understand a problem, and then of course this is depending on the type of problem. If you are working to a construction project, the best thing to understand what type of problem or construction manufacturing is going to the site to see what's going on there. If you are developing a software, yeah, going to the site will not help you to understand. Maybe in this case, you're going to look for go to Gemba, you're going to talk with the software developers. But seeing and understanding the problem yourself, it's quite important. Not to trust on reports, only on key performance indicators. Remember that here I'm talking about confidence level of the data. If it's a key performance indicator or report, sometimes you think it's high, but also it's always good to not make assumptions, because what's the level of confidence that you have? And I've seen sometimes you get data and you say, but this data itself does not make sense. This data itself cannot uh, does not provide the information that you need. So problem solving, it's of course it's a key skill that you need to have, and sometimes because of all types of variants that you can have, might not be easy. For example, I'm just talking about the level of evidence that you have. So what I talk about first, prioritize to solve the right problem. Second, understand the root cause to make sure that you're solving the right problem. Third, understanding the difference between a root cause hypothesis and a root cause confirmation. And if you are moving to a root cause confirmation, understanding before confirming the root cause, understanding the confidence level that you have in the data to solve the root cause. And I've seen, for example, in a project that I had a few years ago, it was a project to develop a new connector for a sensor. And then we had a supplier, and the supplier provided connectors. Then they go for incoming quality in the manufacturing side to, of course, to make sure, because we were releasing the component, so we want to make sure that it was produced according with the spec. And then suddenly the component was outside of spec. And then they started a discussion. We started a discussion with the supplier, and the lab that was providing the data, it's outside of spec. It was a specific dimension, and as part of quality standard, we required the supplier to measure 70 samples, and out of the 70 samples, they were on spec with a very high capability on the measurement that they were doing, and with a very small variation in the measurement that they were doing there. And in our lab, we measured 5 samples, and I think out of the five, they were out of spec. And but long story short, after 1 or 2 weeks of discussion, say it does not make sense, because then we request the supplier to confirm the measurements. They redid the measurement in few extra samples, and they found out the same issue. What we did there? Then we decided to say, okay, let's send the same samples for a third lab that the company had to a different manufacturer site. Still was still in Europe, but let's send for another one to have a third opinion about that one. What we found out is the data that we were getting from the internal lab from this specific factory there was wrong, because it was a new manufacturing site, it was a new lab with new people working on that one, and so they still were in a learning curve there, and they were doing the wrong measurements there. And why I'm telling you this story, because even sometimes you get the data, you need to understand, does the data make sense? And if it doesn't, for example, in this case, the internal lab was telling me, oh, we redid this measurement. I don't know, they did it 2 or 3 times for 5 samples, and it's outside of spec. Then I get a supplier that they said, I measured 70 samples. Everything is on specs. Here is all the data. And once we got the information, they measured extra 10 samples. It's on spec. So it does not make sense. How can it be that you get 8 samples, 80, 80 measured, and everything is on spec, and you look for the capability curves and everything statistically look quite good, and suddenly 5 samples are outside of spec? Something is strange. That's why we request a third part. It ended up that the data that we were getting was wrong. Why I'm telling you this story? This is just a story about a problem solving, and where understanding the type of data, the evidence that you have there, even though it was hard data that we were getting from measurements, does not mean that everything is going to be right and everything is going to be perfect. So when you are working to solve problems, on top of understanding, prioritize the problem, clearly identify the problem, uh, look for the root cause, understanding what's the difference between the root cause hypothesis, and looking for data to confirm the root cause, sometimes you cannot trust the data, because sometimes the data is just wrong. Because maybe the measurement or the assumptions underlying the data, they are wrong. Maybe sometimes how they're connecting the data is different. For example, uh, are you talking about the same way of measurement? Are you talking about the same? You're measuring exactly the same thing. I've seen, for example, companies looking, saying, for time to market. They want to reduce time to market, so that was a problem they want to look for. Then, when you start to investigate, possible solutions to reduce the time to market. And you was clearly seeing that the shortest time to market there, the way they measure the time to market was different from the longest one. So let's assume that you are talking about one goes from A to B and they measure 10, and the other one goes uh, from B to C and they measure 15. And of course, those are different because you're measuring different things. So you get to different results, and sometimes there's a lot of confusion, a lot of organization escalation based on wrong information. So be careful with the kind of data that you have and make sure that you always understand, use the data that you have on hand, but also not use that in a blind way, meaning that sometimes even the data that should be the highest confidence level does not make sense. That's why it's very important if you are looking to solve problems that you work into a team and you have the right collaboration into your team, because into the discussions with your team, the group knowledge cannot the data cannot replace the type of group knowledge. So even though if say sometimes you're using artificial intelligence, you get an answer, it does not make sense. So it's very important for you to take data and you understand that you can have all types of different confidence level, and sometimes even the confidence level should be high. It's not high, so it's up for you and to your team to navigate this kind of complexity. And that's why project management is a very interesting field, at least in my perspective, of course. But that's also why it's not so easy to fully replace, at least at this stage, a project team with artificial intelligence. Because you have the power to say this data does not make sense. Because you can understand, you can see the big picture. And that's here, again, very important for you as a project manager to have this big picture there for the problem, for whatever type you're trying to do, to make sure that you can add value for your organization there. So make sure you like and share this video so it can get more people and more people can learn about project management, about problem solving there. And also, don't forget to subscribe for the Project Management Summit. It's a free event. It's going to be 1 week. The content will be available only on during this week. During this week, I'm going to share 3 episodes, 3 contents with a lot of content for you, exercise, and by then you also get a certificate there. So I'm hoping that you subscribe, and I'm going to see you soon. Thank you. Bye.